All right, let's walk through a price ceiling problem. This is the problem we did in class, but we did it a little quickly in class, to say the least. So notice I have my demand function, got my supply function, and then I've got a price ceiling of $25 per sheet of plywood. So the first step is going to be just to figure out what the market would do without the price ceiling. The next step is to figure out whether it's a binding price ceiling, and if so, what quantity demanded is and what quantity supplied is. And then finally, we're going to need to graph the problem out and identify the area of deadweight loss and take that area. Here we go. All right, so the demand is given by 800 minus 10p. The supply, 50p minus 1000. And then the equilibrium condition, if there's no price ceiling, is that quantity demanded is equal to quantity supplied. So we can just go 800 minus 10p equals 50p minus 1000. Add 1000 to both sides, add 10p to both sides, and we get 60p equals 1800. Divide through by 60, and 1800 divided by 60 is the same as 180 divided by 6, that's 30. And then here I can plug 30 into either equation to get Q. So 800 minus 10 times 30, 800 minus 300, that's 500. So that's my market outcome. I may as well figure out quantity demanded at the price ceiling. I could get that just by plugging in. So I know it's going to be binding because the market price is 30, 25 is below that. 800 minus 10 times 25 is equal to 800 minus 250, that's 550. And then finally, quantity supplied I can find in the same way. Now that's 50 times 25 minus 1000. And it turns out that 50 times 25 is 1250 minus 1000, that's 250. So quite a big shortage, a 300 sheet of plywood shortage. Now, to get deadweight loss, I'm going to need to do some graphing. All right. Usual price quantity space. I know that my demand curve is QD equals 800 minus 10p. It's easier to work with an inverse demand curve, so the equivalent function is p is equal to 80 minus q over 10. So that's going to be a function with a y-intercept of 80 and an x-intercept of 800. It's a straight line, so we can just connect that dot. And then this doesn't have to be pretty. And then finally, the supply curve is given by QS equals 50b minus 1000. Here, to get the inverse, P is equal to 1,000 divided by 50 would be the same as 20 plus QS over 50. All right, so we've got a much flatter supply curve. Something like that. And then we just fill in numbers. And if you're way off, you'll know you're way off because the numbers you got algebraically won't line up with what you've got in your graph. But this isn't too bad. I'm not the best artist, so if I'm a little off, it's not that surprising. But this looks plausible. This is 30. This is 20. And then I'm going to change my pen color. We'll do orange for our price ceiling. So that's 25. And again, quantity demanded goes up by a little bit, 550. That corresponds with what the algebra gave me. And quantity supplied down by quite a lot, 250. I haven't quite drawn it perfectly to scale it, not bad for me freehand with a stylus, which is harder than writing with a pencil. All right, now to get this area of deadweight loss, this is deadweight loss, right? And we're going to assume that the people with the highest willingness to pay actually get the plywood and these people don't. So the surplus that was realized in the free market case that's lost because we have the shortage is equal to that triangle, but we can't find the area of that triangle until we know this value. But notice that this value is just the value of the original demand curve at a quantity of 250. So that actually is pretty easy to plug into the inverse demand curve. P equals 80 minus 25. 250 divided by 10. So that's 55. So I'm going to think about this as being rotated. So I'm going to call that my base. That's 30. And then the height, of course, is 250. And if I take 1/2 times 30 times 250, I get $37.50 per, let's say these were plywood sheets per month. These are dollars per sheet. And then, so this would be $37.50 per month. That's how you do analyze the deadweight loss associated with a price ceiling.